Now we're going to write a program that will interface to what's called an RGB LED. It's called RGB because it contains 3 LEDs inside of one casing. There's a red, a green, and a blue LED, thus RGB. It turns out that if we light up those 3 LED elements in particular patterns, we can cause it to show easily 8 different colors. Well, 7, I suppose, because one of them is actually turned off. So we can easily show 7 different colors, or as we'll see perhaps later on in the semester, we can make it show pretty much any combination of colors that we would like it to show. In particular, today we're going to connect it to pins 7, 8, and 9. So in the setup section of the code, we need to make that cause all 3 of them to be set to output mode. Here you can see that we're going to write a 0 to all 3 of them. That will mean that the LED is turned off, and so the LED will technically be quote-unquote showing black. If we turn on just the pin that's connected to blue, RGB, so the blue is connected to pin 9, then that's going to make the LED show blue. If we turn on just the one connected to green, that'll show green. We can also, I'm going to skip down here, we can also just turn on the one that's connected to red, and so that will just show red. So we have RGB. But if we turn on green and blue at the same time, we get kind of a greenish blue teal color. If we turn on both R and B at the same time, red plus blue gives us purple, or a fancy word, violet. If we turn on both red and green at the same time, this is not obvious from our experience with crayons, but red plus green when you're doing additive light colors actually causes the LED to show yellow. And if we turn on all 3 of them at the same time, then this LED can actually show white. So what this program is doing is it's just looping through all 8 of these combinations with 3 bits. 2 to the 3rd is 8, so this is all of the combinations. Now you'll notice that there's one extra special thing that I did here, and that was I hard-coded delay time at the top of the program. So this is saying that I want all of the delays. You'll notice this says delay, and then the input variable is delay time. Delay, input variable is delay time. Before we would have put a number in here. I would have said 1,000, for example. But I don't want to do that anymore. I want to have this be a variable. Because if I change just this one number up here, then it's going to change all of the delays throughout the entire program. So first I might run it at 1,000 milliseconds, and then I might want to run it at 500 milliseconds. Heck, if I wanted to go really fast, I could run it at 100 milliseconds. So that means that it's going to take only 1/10 of a second on each color. But notice that I only have to change it in one place up here. You might say, what is this int? Well, that just says that whatever this variable, delay time is going to be an integer. And an integer just has to be a whole number, positive or negative. It can't have a fraction, so obviously 1,000 is just fine, but 1,000.5 would not be acceptable as an integer. So we're going to declare this up at the very top, and then within each of these calls to delay, it'll change the delay based on the variable, or based on the value that we assign to delay time up at the top. So now that we've seen how to write the program to support the RGB LED, it's time for us to actually look at the circuit that we're going to use to implement it. Now here we can see this is an actual RGB LED, and for one thing you'll notice is that it has 4 terminals. Now one of those terminals is the longest one. That's the ground terminal, which is common to all 3 of the LEDs, and then there are 3 other terminals on here as well. The shortest one over here on the far side, that's the blue terminal. Next to the ground terminal, that's the green terminal, and then over here by itself is the red terminal. So you'll have those 4 terminals that you need to attach to the board. Now I've already attached those 4 terminals to this board, and so we can see this is how the board is connected. So we have in this circuit, we have the 3 wires coming from the Arduino. Those are connected to the R, the G, and the B. Here you can see this is the RGB LED. We have 3 resistors. These are the current limiting resistors. Those are very important. Don't forget those. 330 ohms for each one of them. Notice that it's not going to this terminal because that's the longest one. That's the ground terminal. And instead of having a resistor attached to it, that's going through this wire to the ground connection of the board. And then, of course, over here we see that that ground connection is actually attached to the ground connection of the Arduino. So when I download the code, or rather when I upload the code, what I should see is that this LED will flash 8 colors at 1-second intervals. So technically, the first color is going to be quote-unquote black because none of the 3 LEDs will be lit. So I'm uploading the code right now, and well, I have to verify the code first. So verifying the code, and now I'm uploading the code, and you can see that the colors are in fact flashing. So I'll wait until it cycles through. It'll go black, and then blue, green, cyan, red, purple, yellow, and white. And it'll cycle through those over and over and over again. Now if I go into the code and just change one number, which will be the delay time, and if I recompile, verify, and then if I re-upload, you'll notice that the code is uploading, and now it should flash much faster. And sure enough, we're seeing that those colors are flashing much, much faster, having just changed a single number in the main program.